So thanks everyone for joining today. I am Mike Darmitz from Sheridan College's Screen Industries Research and Training Center, or CERT for short. So I'll be hosting today's webinar. So hopefully everyone's excited to hear a little bit more about this project, M-Body.AI. So first, go over the agenda for today's webinar. So we'll start off with a bit of an introduction to both the project as well as our research team. Then we're going to go sort of in the flow of data that pertains to this project, starting out with how we're capturing the data being used in this project, then to how we are processing that data after capture to make it ready for use. Then next after that, how are we actually using that processed data for generative animation, as well as some details around that topic. And then we'll speak a little bit about the open source software tools we're creating as a part of this project, of leveraging the data and generative animation elements. And then a little bit about collaboration. So this is an open collaborative project, which is a big reason we've invited all of you here to join us today. So we'll speak a bit to those details. And then finally, about some of the work that's already been conducted as a part of this project. And then at the end, hopefully we'll have a bit of time for a question and answer session. So stay tuned for that if you have some questions you'd like to ask. So also you can post questions in the chat during the meeting. You can post them in English or French. We won't be handling questions during the presentation, but we'll try to get to them after we're done. Now there is also slides available if you want to follow along on your own, both in English and in French. And Jean-Francois, I believe you're going to post the links in the chat.
Yes, it's done.
Okay, great. So if anyone wants to have those slides to look at on their own, take a look in the chat. You should find a link there, both English and French. And as Jean-Francois mentioned, we are recording this presentation and we will provide this to everybody afterwards. Okay, so what is this project even about? So M-Body.AI is a bilingual applied research project. So we have participants from both Ontario and Quebec, French and English speakers. And our real goal here is to accelerate both the advancement and adoption of generative human performance technologies. So what I want to emphasize here is we're not trying to make a commercial product that competes with other products out there. We're really trying to help advance those products and help people make new products. This project is federally funded by NSERC, so Canada's National Sciences and Engineering Research Council. Okay, so a bit about our high-level goals, what we're really trying to achieve with this project. So as mentioned, we're really trying to support advancement of AI research in the area of human motion generation. We also want to make it easier to put that research work related to human motion generation into practical use. How do we take it from academia to tools that people can actually leverage? And it's also a big goal of ours to make sure that all the outputs are publicly available and free to use, including for commercial purposes. So to achieve these goals, we are planning on creating deliverables in 3 different areas and targeting 3 different groups of users. So firstly, for academic and applied researchers, we will be releasing a data set of multimodal, multi-agent interactions, and you'll be hearing a little bit more about those details. And we're hoping that that will help support other researchers in their machine learning work. For tool developers, we are also creating open source software systems. And again, the whole focus of these is to simplify the integration of generative character performance models into industry standard content tools. So when we say industry standard tools, we're talking about things like tools like Maya, Unity, Unreal. So all of these tools that people are leveraging for modern content creation. And finally, more focused on actual animators, we will be releasing reference generative character animation tools. So these will provide an example of how both the software systems and the data we've created, how they can be leveraged to create tools for animators to use. And hopefully that'll be a helpful reference to others out there. Okay, a really high-level view of our research team before we hear a little bit more. So we've got Sheridan College's Screen Industries Research and Training Center, or CERT. From Cégep de Matin, we also have CETRIN, le Centre de Développement et de Recherche en Intelligence Numérique. Apologies for my French. We'll have some better French speakers on in a moment. From Durham College, we have the Mixed Reality Capture Studio, as well as the AI Hub. And finally, from Cégep de Rivière-du-Loup, we have LEO, or Le Laboratoire en Innovation Ouverte. So let's hear a little bit more about the research centers and the researchers participating. So to speak to CERT, I'm going to throw to my colleague, Stefan.
Thanks, Mike. So hello, everybody. My name is Stefan Kozak, and I'm one of the PIs at CERT. My main focus is in CG animation and visual effects. And so a little bit about CERT. We are one of 5 research centers that are from Generator, research team of Sheridan College. We're dedicated to driving innovation in Canada's screen industries. Behind me, you can see that we're at this downstage located on the lot of Pinewood Studios, and we're in the heart of Toronto's vibrant film production hub. As a federally funded technology access center, we empower Ontario's screen industries with cutting-edge research and a depth of knowledge in the production pipelines. Our mission is to help support the industry innovate through advanced technology and our domain-specific expertise. We typically collaborate with small and medium-sized businesses, leveraging Canadian grant support to monetize our joint efforts. And this support helps us build teams, develop technology, and employ students as researchers from programs within our Sheridan College's Faculty of Applied Science and Technology and the Faculty of Animation, Arts, and Design. And this collaboration provides both students and partners with hands-on experience contributing to the innovation and driving the evolution of the entertainment industry with fresh ideas. And it's interesting to note that these ideas generated in academia help propel the industry advancements, while real-world industry challenges inspire academic research and curriculum development. This symbiotic relationship ensures that both sectors continuously benefit and grow, fostering a dynamic environment where innovation thrives. Next slide, please. So within the entertainment industry, we're evolving alongside the latest trends in technology, helping our partners grow with cutting-edge developments. And these are the main focus areas that we are doing at the Screen Industries currently, and they evolve with the evolution of the industry. In virtual production, we are integrating cutting-edge motion capture systems and real-time technology to create realistic and integrated visuals directly on set. And this approach not only enhances the creative process, but also provides real-time feedback and adjustments, making production more efficient and cost-effective. In animation, particularly in virtual humans, we are pioneering and developing the digital human pipelines and workflows that significantly enhance character interaction and engagement. And our expertise enabled the creation of lifelike virtual characters that can use AI to interact seamlessly with digital environments. In software development, we focus on integrating and developing advanced software solutions tailored for media and entertainment. Whether it's interactive experiences, mixed reality applications, or film production tools, we're dedicated to driving innovation and ensuring that partners stay on the cutting edge of technology. Specifically in the M-Body project, we're leveraging our expertise across these various domains to capture performances by using the cutting-edge technologies to create accurate animations. We're using character and animation standards to produce production quality dataset. And we're also implementing and creating software tools to support M-Body through the various stages of the generative animation pipeline. Thanks, Mike.
Great, thanks very much, Stefan. And so next, to speak to the Durham College Research Centers participating, I'm going to go to my colleague, Jason.
Thanks, Mike. Hi, everyone, and thanks for joining us here today. So my name is Jason Hunter. I'm the manager of the Mixed Reality Capture Studio here at Durham College. And I'm here to introduce you to two research centers here at Durham who are involved in the M-Body project. First is the MRC Studio. We work with small, medium enterprises in the area, including immersive media, gaming, training and simulation, amongst others. And our goal is to help companies adopt immersive technologies or optimize existing workflows in their current businesses. Lately, our work is focused in mixed reality development, digital twinning of spaces and objects, and digital performances for immersive media. The AI Hub at Durham College helps companies unlock the full potential of artificial intelligence by leveraging their own data. So they follow an ethical framework and in everything they do, ensuring responsible AI adoption, and can support companies at all stages, such as AI strategy, development, and deployment. Next slide, please. So our contribution to the M-Body project is on two fronts. First, in capturing and contributing performance capture data to the overall data set. This is using our vision-based markerless motion capture system. And exploring data fidelity from various motion capture systems has been a really important part of the research so far. It helps validate which contributions are most effective to the model, and also provides us the opportunity to explore how performance capture might be conformed to future model training. The second area that Durham contributed to the project is from the machine learning side through patterning, model testing, and AI implementation. So our team supported in comparing existing open source datasets, training and fine-tuning with new generated data, and evaluation of dataset quality and results. So with the Mixed Reality Capture Studio and the AI Hub co-located in the same building, we offer seamless collaboration and are just very excited to be working with the other leading centers as part of the M-Body project. Thanks very much.
Great, thanks, Jason. And next, we're going to go to Sherry to speak a little bit more about Sheridan.
Hi, everyone. My name is Sherry, and I'm an AI researcher at Sheridan. So Sheridan is a research center affiliated with the Cégep du Matin, based in Matane, Quebec. But we also have offices in Quebec City and Montreal. We are mainly targeting the entertainment sector, including video games and animation, but we also have a lot of projects in environment, healthcare, and education. And we are a team of 20 people, including AI researchers, R&D programmers, 3D technical artists, and more roles within the team. Next slide. And as an applied research center, we are offering technology monitoring and foresight, proof of concept, prototyping, implementation, and competent transfer and specialized training. And we are offering these services in different areas, such as computer vision and AI, rendering, animation, 3D reconstruction, synthetic data generation, and production pipeline. And our main contribution to this project is mostly on the ML AI side of things, including technology monitoring, AI model selection, data processing, model evaluation, and development if needed. Thank you, Mike.
Thanks, Sherry. And last but certainly not least, we're going to go to Marjolaine to speak a little bit about Leo.
Thank you, Mike. Hello, everybody. I'm a project manager and researcher at Leo. At Leo, we foster the adoption of open innovation practices involving the user. We are a college transfer center in innovation social practice affiliated to the Cégep de Rivière-du-Loup. Our team is around 18 people of researcher, facilitator, and designers. Next slide, please. Our role is to enhance the capacity of companies and organizations to innovate by generating solutions both internally and externally. In the context of M-Body.AI, this means, among other things, that we collaborate to set up ways to consult the community and implement tools to mobilize researchers, developers, and studios around the project. We also have a student research creation project on the ethical challenge of AI.
Yep, thanks very much, Marjolaine. Okay, so with this diverse and talented team of researchers, what are we actually doing as a part of this project? So as mentioned in the agenda, we're going to follow the data through the pipeline. So first, it starts out with the dataset capture. So we're going to throw to Spencer from CERT to tell us a little bit more about what data we're capturing and how we're doing it.
Thanks, Mike. Hello, I'm Spencer Edenoy. I'm the virtual production lead at Sheridan Search Center, and I'm focused on facilitating the dataset capture and preparing the raw data for processing with our virtual production team. So dataset challenges. When we consider the challenges with current available datasets, there's a few main points that kind of stand out. Existing datasets are often low quality in terms of technical specification. They can sometimes possess, retargeting errors or other errors like noise or skating. And there are inaccuracies when it comes to hand and finger capture. Datasets can also be limited in terms of diversity, in terms of the distribution of data with regard to like emotion or style or based on other classifications. And many datasets lack geometry or skeletal meshes, or may have inconsistent geometry. Generally, humans have quite diverse body proportions, and existing data is often normalized to a single skeleton, which can result in geometry penetration from poor retargeting. Most datasets are not commercially usable and offer limited channels of data. Next slide, please. So to address some of those challenges, we have our human motion data set. For our data set, we plan to capture at least 20 performers, likely going to be a few more than that, but we're at minimum going for 20, 10 male, 10 female. And we're aiming for approximately 30 hours of 2-agent conversations. At a high level, we capture the 2 agents standing face to face, having a variety of conversations that cover a range of performances from general conversations to more specific scenarios intended to elicit certain gestures. The data streams include full body performance capture, which covers 3D skeletons for body, hands, fingers, and head, spoken audio separate for each agent, timed transcripts of the spoken audio per agent, raw facial performance capture data, which includes video, audio, and depth data, also video reference or the witness camera of the capture session, and a body scan that matches the proportions of the source performer. Next slide, please. After data is captured, it will be synchronized, processed, and applied to the target character mesh. This image is just an example. Our final meshes will be proportioned based off of the scan of the performance. However, we do plan to also normalize the data so that both options are available for use, as there is certainly use cases for both data sets. Next slide, please. During each capture session, we conduct a full body photogrammetry scan of the actors, then conduct a series of motion capture exercises. This involves capturing an emotional range of performances, some scripted material that helps guide performances that cover the more emotional regions of the emotion spectrum. And then finally, we capture improvised conversations that intend to elicit various categories of conversational gestures like emblems, illustrators, regulators, beat gestures, just to name a few. Next slide, please. Our capture method involves capture with a 44 camera optical motion capture system, an OptiTrack motive system at the Search Center. With that system, we use the Manus gloves for hand tracking. Also contributing data is Durham College using their Capture system, their 16 camera markerless mocap system. Simultaneous to the actual mocap data, we're capturing facial performances as well on the iPhone. So that's giving us the video, the audio, and depth data using that true depth sensor on the iPhones. And we're also capturing clean audio using lavalier mics and shotgun mics, and intend to, well, they are captured discreetly, so we intend to isolate that as part of the data. Next slide. And that's our approach to capturing. Back to you, Mike.
Great, thanks a lot, Spencer. So as earlier mentioned, one of our goals is to create a really high quality data set, so where the animation is very high quality. So rather than releasing the raw data directly, we need to do some processing on it. So we're going to go to Stefan from CERT to talk a little bit about what we're doing to process all this performance data.
Thanks, Mike. Yeah, so in terms of processing, like Mike just mentioned, our plan starts by addressing the quality of animation that is currently available in animation datasets. Developing a production quality dataset involves creating and maintaining standards for animation and character consistency. Each dataset must undergo extensive quality control to meet these standards involving detailed check and refinements. This process ensures that the final dataset can support the high demands of modern animation and character design, enabling realistic and believable performances. Next slide, Mike. So here is a slide that outlines the processing challenges that currently exist. One major issue is the posture correction, which often arises from retargeting characters with skeletons that have different proportions. This also comes from incorrect motion capture solves, such as improper marking matching, synchronization issues, and Euler angle problems, such as like gimbal lock and interpolation issues, and order dependency and improper angle solves. Foot sliding, seen in most raw footage, requires correction of micro movements and addressing geometry intersection with the ground to ensure that there's a proper foot roll, which also speaks to having the right bone density and defining the required movements. Root shifting, often found in inertia systems, poses another challenge because vertical positioning can be incorrect due to the improper calibration and rest pose offsets. Noise in the data is typically caused by occluded markers and synchronization issues, and this leads to solves with joint axis flipping and demands cleaning to ensure accuracy. Geometry intersection is probably the biggest and most significant problem, and inaccurate body proportions are essential, and creating accurate body proportions is essential for precise positions of these interactions. So to tackle these challenges, we've developed the production quality system utilizing the procedural character pipeline. Next slide. Yeah. Our production quality system uses the procedural character pipeline to address and improve upon the errors commonly found in raw data, and with most animation datasets being used. Through processing, we transform this raw data in precise actions to eliminate capture errors, including the issues found in triangulation of noise. Our goal is to accurately replicate the exact actions of actors from the capture sections while improving the incorrect data captured from the initial solve. This entire pipeline is built on characters with standardized topology, rigging, and control systems, ensuring that consistency across the different character proportions are involved in this project. Accurate proportions, most existing datasets commonly use a retargeted naturalized proportion with standard meshes and skeletons. With M-Body, like Spencer mentioned, we're going to capture the variations found in the diverse sample set of actors, retaining realistic skeletons and geometry proportion. This approach allows us to mimic the actors' movements and the 3D models accurately, matching their natural behaviors and motions. This can be used to extract and identify precise human movements, which include accurate joint rotation and human contact information. Error mitigation. Our process system incorporates the human inverse kinematic retargeting system that solves for precisely mentioned realistic joint rotation, noise removal, and foot sliding corrections that was mentioned before. This ensures that movements remain true to life and minimizes the discrepancies from real actions of the actors. Lastly, our retargeting system implements a bunch of automated batch processing systems that minimize human error, enhancing the overall reliability and efficiency of our processing workflow. We're also processing using a visual validation system to ensure that captured data accurately represents the captured performances, matching performances to markup values. Additionally, our system is using automated tools to seamlessly transfer and interpret data between the industry standard animation software such as Maya, Unreal, and Unity. And for data processing workflows to identify, store, and match data within machine learning models. Next slide, Mike. And here is an outline of our M-Body processing. The inputs and outputs from the user from an animation to the outputs which are intended to be FBX and BVH. And we're also investigating USD as well. We've indicated the user decisions that are made through modifications from our animation team. And you can see the series of steps from visualization, the tools that we're using for visualization, machine learning, where we're checking the results and adding to the data library, and the automation that we're trying to, again, to use automation to prevent any errors from human inaccuracies. And that's it. Thanks, Mike.
Great. Thanks very much, Stefan. So now with all of this data that we've captured and processed to make sure that's high quality, whole purpose of that is so that it can be used for machine learning applications. So we're going to go to Sherry from Citrin to speak a little bit about some of that generative animation work we're doing as a part of this project.
So I'm going to start by asking this question. Why is it difficult for researchers to work on new animation solutions using ML? And so firstly, it's difficult to validate these solutions in production because there's a gap between what researchers are doing and what's being done in the production. It requires a lot of customization of the data preprocessing code. The existing datasets are small and non-diverse, and it poses a challenge for researchers. Also, specifically for the conversational gesture generation, gestures are idiosyncratic and complex in nature. So it means that gestures are highly individualized and vary from person to person. Also, contextual integration. Gesture generation requires a deep level of understanding of conversational settings, speaker identity, emotions, semantic content, and environmental factors. So for example, the way I'm talking in this webinar is different from the way I'm usually talking at home. So that's the environmental factor. Also, there are challenges in evaluation. So objective metrics are currently unable to fully assess the semantic depth and motion quality. Next slide. So I wanted to go through some of the generative animation use cases in general. The first use case is motion synthesis. So given inputs such as text, audio, this includes speech or music, character identity or style, motion category, initial pose, also known as seed gestures, and the scene or objects in the scene. So using these inputs or a subset of these inputs, generative models can generate motion. Motion completion or in-betweening is when you have a start pose and you have the end pose and you want to generate the intermediate poses using AI. Style transfer is when you have the style motion learned by the model and you have the content motion unseen by the model and you want to transfer the style. And crowd animation, simply generating animation for a large group of agents. And rigging for articulated character in this context is using AI to, starting from an articulated mesh, extract the skeleton which matches with the animator's expectations and in terms of joint placement and topology. Next. So we decided to look into the Genea challenge because Genea challenge is a challenge that's focusing on conversational gesture generation. And that's the exact same direction we are focusing on. It has two entries, 2023 and 2022. 2023 challenge is a large-scale evaluation of gesture generation models in monadic and dyadic settings, meaning that there are two agents having conversation with each other. And it uses a dataset called Talking with Hands. This dataset contains motion information in BVH format of the two agents. It also contains the audio information of the agents speaking and the transcription of the audio. It focuses on two aspects in evaluating the models. The first aspect is human likeness, which is basically how human-like and natural are the generated motions. And the second aspect is appropriateness, which is how appropriate and relevant are the generated gestures with respect to the audio and the content of the audio. We realized that the Genea challenge is not a competition, so they didn't explicitly specify the top models, but it was anonymous, but just looking at the metrics, we realized that one of the models called Diffuse Style Gesture Plus was the runner-up model in this challenge. And it's MIC license, so it matches with our criteria of open source. It also obtained a reproducibility award by the Genea committee. And also we used 0x in our evaluations as well. It's one of the top tier models in 2022 challenge. And it's a variational framework for audio-driven gesture generation with zero-shot style control by example. And this means that given a short motion clip in any style, the model can generate longer duration motion in the same style, even if the model hasn't seen that style before in the training, which is that's why it's zero shot. Next slide. So let's look at the diffuse style gesture plus a model in more detail. As the name suggests, it's a diffusion-based process, and it's also multimodal. It uses speaker ID, motion, audio, transcription, and the seat gestures. And these modalities are mapped into a latent space, to a hidden space, which is also called latent space, and processed by the diffusion model to generate new gestures. And the way it's done, similar to any diffusion process, at every step, a noisy gesture sequence, along with some conditions such as seat gestures, audio, speaker ID, and text, are fed to the model, and the model is expected to predict the noise. Some of the features that they've used for gesture, they use position, velocity, acceleration, rotation metrics, rotational angular velocity, and acceleration for each joint in each frame. And you might think that some of these information are redundant. For example, acceleration can be derived from velocity, or even position can be derived from rotation. But it turns out that using more information, even if it's redundant, helps the model to learn faster and better. For audio, they use a combination of MFCC or mel frequency Cepstral coefficients, mel spectrum, pitch, energy, wave LM, and onsets. And for speaker ID, it's just a number, so they use one-hot encoding. And for text, they use a model called fast text to extract the 300-dimensional word embeddings. Next slide. So maybe one of the most interesting parts is how to evaluate these models. So let's assume that we have a generative model that can generate motions. How can we evaluate it? So up to now, human judgment remains the gold standard. and objective metrics are not yet as good as human judgment. So for example, in the Genia challenge, they use humans and they ask people to rate the animation based on different factors and then calculate the mean opinion score. Even though qualitative metrics are the gold standard, we still need the quantitative metrics as well for many reasons. For example, you want to use it in your validation as a metric, or you might not be able to afford the qualitative metrics every time. So we realize there are so many metrics out there used by the researchers, but some of the most reliable and most common ones are FID, or fresh inception distance, which is also very common in image generation. In the context of generative animation, it's also called FGD, or fresh gesture distance. And it's the fresh distance between the generated motion distribution and the ground truth motion distribution. All these metrics are applied in the latent space. It makes more sense to do it in the latent space, even though some of researchers use them in the raw space or joint space. And also, for example, some of these models use text prompt to generate the motion. So they ask the user to input a text prompt and they use it to generate the motion. The model will generate the motion based on the text prompt. So they extract the co-embedding space with co-embedding of text and motion to use these metrics. So for example, our precision is the rate of current motion prompt pair matchings. Also, diversity measures how many different poses or motions have been generated within a long motion. In other words, it measures the variance of generated motion in the latent space. And multimodality estimates a variance for a single prompt. So for example, for a single text prompt, randomly generate some number of motion sequences and then measure the differences between these motions. And finally, multimodal distance is the average Euclidean distance between the generated motion embeddings and its co-embedding of the prompt used for generation. And also some people have used, for example, for audio, they used other metrics such as beat consistency score, which measures the motion audio beat correlation. Yeah, next slide. So what we have done so far, we have trained the diffused style gesture plus, or DSG plus for short, using our initial motion capture in talking with hand format, plus talking with hand data. And we are planning to compare it against talking with hand using the metrics I just mentioned. We also plan to correct the errors in the talking with hand data, as Stefan mentioned. Some of them include realistic joint rotation, noise removal, foot sliding, and weight correction, and more. And then combine them with our initial mocap data, and we are expecting to get better and higher quality animations as we just clean the data. We also plan to train DSG Plus using our new dataset and perform qualitative and quantitative comparisons. And again, we expect to get higher quality results. And one interesting thing to try, we are interested to verify if the model that's trained on skeletal data with accurate proportions performs well, meaning that, and so most of these existing data sets, they use normalized proportion bones, but we're interested to see if we can use different bone lengths for different people and still get good results. Thank you, Mike.
Great, thanks so much, Sherry. Okay, so we've covered a lot of the aspects related to machine learning here in supporting the more research side of things. But as mentioned at the beginning, we're also really trying to make it easier to take the results from that academic research and allow people to use them. And so this is where the software side comes into play. So I'm going to speak a little bit more to what we're doing on the software side for M-Body. So starting out with challenges. So why is it difficult for people to take some of these machine learning models or other research and actually create tools utilizing it? So firstly, it often requires expertise in multiple domains. So unlike a lot of other programming work, you can't just know a programming language and expect to be able to do this sort of integration. There's often knowledge required to developing for a specific tool and also related to machine learning that's required to do this successfully. Also, often you'll need to implement custom data type conversion. So the outputs that you get from a machine learning model won't typically be what you can use directly within a tool. And kind of similar to the first point, there's also a mixture of programming languages involved. As a lot of you probably know, Python very commonly used on the machine learning side, but we'd be using more C#, C++ in a lot of the tools, especially game engines that we work with. There's also a lot of complexity involved in setting up dependencies for some of these machine learning models. And finally, you can often have different features that you'd like to leverage existing in different tools. So this can lead to very complex workflows where you want to use one tool to do one thing, another tool to do another thing, and then you've got all this data exporting and importing through that pipeline as well. So it can get very complicated, be hard to develop pipelines and tools. So the goals that we've set for this project on the software side, we really want to ease the integration of these generative animation models into tools or production pipelines. As mentioned, some of the tools that we're looking at supporting are Maya, Unity, Unreal, but also hoping to support other commonly used tools in the future as well. Could include things like Blender, other animation tools like that. And we really want to allow people to access these generative models from those industry standard tools. And again, all open source, free, and commercially usable is a big part of this project. So in order to look at the software side, we wanted to figure out what are the challenges with taking these models, bringing them directly into tools. And so we looked at a few different approaches to integrating models. So one of the options was ONNX, or Open Neural Network Exchange. So in this case, it takes a model developed with tools like, say, Python and PyTorch, maybe TensorFlow, and converts the model into a common set of operators. And then a tool can use a runtime to kind of execute those operators. Could be directly from Unity or from Unreal. So a really good thing about this is it reduces external dependencies. As long as you have that data of the operators, you don't really need anything else installed. But the big issue we found is with the converting of those models, sometimes certain features aren't supported. Sometimes you'll get errors where the model just does not run correctly or run at all after it's been converted to ONNX. The other big issue is there's often a lot of data pre-processing that needs to be done before you send that data into a machine learning model. And this is not supported by ONNX. So that data pre-processing would have to be ported to another programming language or executed separately, which is complex. Another option is to actually embed Python execution into an application, for example, using a library called PyBind. So yeah, as mentioned here, in this example, we're taking an actual Python runtime, integrating it so it's part of our application, and then using that to execute Python code. So this does reduce some external dependencies, which is great. You don't have to have users installing Python on their own systems. But the big disadvantage here is you would typically require some wrapper around that Python code in order to call into it. And we also found issues with inconsistent execution. So cases where running with Python in the normal way worked properly, running with this embedded Python, we would get errors from things like lower level software libraries working with the graphics drivers. And finally, most straightforward way, just using the operating system command line execution. So this is the way these models are typically run when they were created in Python. And so the great thing about this is we can use the models as they were created, use all the data pre-processing that was created for it as well. And we'd also expect the execution to be consistent. The downside of this is we do require all those external dependencies to be present. So on a system using this, we would have to have Python installed. We'd have to have any libraries or modules it's dependent on installed as well. And so for this project, we have been focusing mainly on the third aspect here. So just using command line execution. But we've really been trying to create things to make it easier to leverage those command line tools. So as a part of that, we're developing tools in sort of two high-level areas. So firstly, we have our M-Body library. So this implements a generic node and graph structure system. So where we have nodes that execute small pieces of specific functionality. For example, it could be loading a file from disk, could be one small operation. And then allowing the connection of those nodes together so that data can flow from one node to another, creating a pipeline or graph. The system has been implemented to be completely multi-threaded as well as automated. So this is one of the goals to simplify this execution. So every node executes on its own thread on the CPU, so nothing will kind of block or hold up the application calling to it. And also nodes will execute automatically as soon as they have data available. So it prevents programmers from having to write their own code to check when data is ready and pass it on to the next thing. That's all automatic once the node structure is specified. We've also implemented a bunch of helpful utility nodes. So this would be things like file reading and writing, as well as inter-process communication. So the ability for a node on one system to send data to a node on another system. Main reason we would want to do this is we may have a machine learning model that only runs on Linux, but we may want to leverage that from, let's say, the Unity game engine running on Windows. So this would typically just be done manually. Someone would have to run the thing on Linux, take the results, transfer it over. But with what we've implemented, that can all be automated, where we call from Windows to Linux and then results sent back to Unity automatically. This library is written all in C++. And provides a C-style API just to make it kind of universally integratable into different software tools. And currently, we are building it for Windows and Linux. And the other facet of this is the tool-specific plugins. So these are intended to provide a user interface in a tool-specific way. So the way that we would want to leverage a tool in Unity is going to be different from in Maya. We'd have different ways of creating that interface. So that's part of the tool-specific plugin. This also allows us to handle configuration and selection of inputs directly from the tool that we want to use. So this could be, for example, selecting an audio file that we want to generate an animation for. Very convenient to do that right from the tool rather than to have to go somewhere else to specify that. And then finally, like, we need to apply the pipeline results in a tool-specific way. So to save a user or developer from having to go and take the outputs, manually copy them into a project, and say set up import settings, we can automate that process so that once you've generated an animation, you can see it directly in the tool you're using. Yep, and as mentioned, really targeting industry standard applications and really hoping to make it easy to expand the applications that support the use of these software components. So a lot more to say about these software tools, but we don't have a lot of time today. So we are going to move on to the ways in which we're trying to collaborate both with industry and academia on this project. And we'll go to Marjolaine to speak a little bit more about this.
Can I have the next slide, please, Mike? Your input is essential because your needs are at the core of what we do at M-Body.AI. That's why with the help of Sidheim, we set up platforms soon available where we look forward to foster interactions. In the meantime, right now, you will also find a form on our website which allow you to let us know that you are interested in sharing your experience with us, experiment, or stay tuned. I will put the link in the chat if you are interested. Next slide, please. To ensure that the project is fully available in open access, we have set up licenses that allows for commercial use. They are well known in the industry and for research purpose. They are also easy to use. We are faced with, so we have two types of license for code and software systems. It's MIT Expat, and for the dataset and documentation is Creative Commons by 4.0. We are faced in this project with ethical issues concerning the dataset and the licenses were chosen taking this into account, making sure we respect moral rights, personal image integrity, and personality rights. The next slide, please. There are several options for collaborating in the development of this research project. You can choose to stay tuned, keep up to date with the progress and result of the research project by signing up to receive the research publication. You can experiment, register as one of the partners interested in taking part in demonstration session, Scrum, interviews, and user tests to inform research with your needs and requirements. This will give you the opportunity to become an early adopter of the system in your workflow, and you can be participate to the co-development, express your interest in joining a co-developer community once the open source coding infrastructure will be in place. And I give back the microphone to Mike.
Thanks, Marjolaine. So yeah, very much hoping to work with as many of you as we can. And so finally, just to make it clear, of all the things we've spoken about today, what has already been accomplished versus what is still to come. I'll speak just a little bit to the work that we've done so far. So main areas we've been working in since we started the project. We did conduct background research into existing literature, as well as tools and data sets related to generative animation. And at the same time, consulting with industry and academia to try and identify what are the major issues with them leveraging generative animation, as well as what they would want to leverage generative animation for. We have captured a preliminary multi-agent animation dataset already. We've also set up existing generative animation models to validate that data. So Sherry was speaking a bit to that work that's been completed. And finally, we do already have prototype software tools that I was speaking to help with that integration of ML models. The tools currently support Unity and Unreal. Maya will be to come in the future. We have also created initial Python API to leverage our tools directly from Python. And just a quick look at our original timeline for this project. So currently, I guess we're just after Q2 second quarter of this year. We're aiming to release the first open source version of our generative character animation tool, as well as the M-Body library, and also a sample data set, so a small sample data set of multi-agent conversational animation. So this will be coming very soon. So we expect within the next couple of weeks that we'll be putting that first open source data out there. So hope everyone here is excited to get a look at that. Afterwards, we'll be doing demonstrations of the prototype tools as well as the data set in order to gather feedback. And we'd love to do some further testing and validation with industry and academic partners. By the end of the year, we'll be looking to release a next major version of our generative animation tools. And we also aim to have a full data set of multi-agent animations out by that time. And finally, project will be aim to wrap in Q2 of 2025. But we really don't want the project to stop there. So the plan is to set up additional research projects, either to extend this work or to explore integrating this work into tools and pipelines that others are working with. All right, so we've reached the Q&A section of this webinar, and just got some information up here while we go through the Q&A. In case anybody does want to reach out to us, you've got a few ways to contact us. So you can see the slide here for email address you can use to reach out, as well as our website and social media if you want to keep track of what's going on. We've got some exciting things coming up in the near future. So Jean-Francois,
Yes.
we're going to go through some of our potential questions that we see in the chat. I noticed a lot of unread messages that I have here.
That's okay. That's why I've taken note of these questions, and I was wondering if I go through them from the first one that appeared, or if I stay in the different themes that were covered. But I'll start with the first one that was asked from Alex, who's asked which licenses are used for M-Body tools and what factor influence the decision for choosing those licenses. So I guess I'll pass the mic to Marjolaine to go into that.
Yeah, we had to take into account that we want the content to be commercially usable and also open to researchers that need to experiment or want to experiment with the data set. And also that the human body and voice come with identity and make sure that everybody's protect and feel secure in the environment we put out. So we did some comparison, and it's why we've chosen MIT and Creative Commons.
So Alex, you're satisfied with you have another reply to this question, to this answer? You can open your mic.
Yeah,
Sounds good. Okay, you're good. Thank you. So don't hesitate if you have to rephrase or just to more specific information in the question. You have the possibility to engage in conversation. So next question was from David Dexter. He asked, does age make any differences in capturing? So I guess maybe Spencer, can you go and take this question?
Yeah, absolutely. Age makes a difference. We would like to accommodate or include a variety of ages, but with the challenge of sort of the open source nature, we are slanting towards the younger demographic at the moment, and we do have made some observations on that age factor. But yeah, that's something that we want to try and get some more diversity as we move forward through the rest of our capture sessions.
All right. So we can, if you have anything to add, David, floor is yours if you want to open your mic.
No, I'm all good. That's great. I was going to volunteer since I'm older to be one of your models.
Absolutely. Be our guest.
Expect to receive a call from us then.
Thanks.
Great work, guys.
Thank you. Alex has another question. He asked, is open data available only after it has been processed? Is there any chance for crowdsourcing the processing? So maybe if Stefan or someone else from the team want to answer to that?
Sure.
Yeah.
I think right now, yeah, we're trying to maintain these strict standards, and we want to make sure that the initial data set it falls within everything that we're doing. So it's going to be processed by us, but that is very interesting of opening it up to the future. So in the future, we are planning to have others integrate into the models. And one of the reasons why we are and we're working with Durham is because they actually are providing a totally different way of capturing, which would account for other people's systems and how they could integrate into our pipeline, and whether or not they can be used to train their own sample data sets. I don't know if anyone has anything else to say on that.
Yeah, I'll add one point there as well. So when Spencer was speaking, he mentioned that we are also capturing facial performance through video and audio. But just due to the scope of this project work, we aren't planning to process that data. So to release the actual facial animation data through, let's say, like blend shapes. So that is a case where, we're capturing that data so that it is possible to process that and use it in conjunction with the body animation. But if we aren't doing it ourselves, maybe that's a possibility to crowdsource that work so that that data can be put to use. So yeah, I really appreciate that question.
Awesome. So another question from Alex. I hope I'm phrasing in the right way, so don't hesitate to add. He asked regarding qualification, or is field work conducted as part of the project? Is that right, Alex?
Yeah, on qualitative research, if there's been field work going on in any kind. Apart from interviews that sounded a little bit more directed than semi-directed, but maybe Valjanin, you've been involved in that, or?
We gather information on every participant to make sure our sample is as diverse as possible, but there is not other information that are gathered at the moment. Does it answer your question?
Awesome. So there was also another question regarding probably the processing of collaboration. Alex wanted to maybe develop a little bit on the design thinking. So you asked about that. Are you interested about maybe the methodology that we are using for collaborations involving users? So I can say maybe a little bit on that because the question was really short, but the idea is really to have a mixed method using more traditional ethnography when we go into research process, conducting interviews, getting in touch with different actors, partners to acquire the needs, and understanding the pipelines and the different pain points, during so there was different phases on the project. So really there was the more environmental analysis on a different scale at the different levels. So in the field work, in the also in the literatures, understanding what's available out there in terms of information to understand, and the needs and to conduct the work. Probably Mike can go a little bit deeper into, the development of the actual, softwares and the actual deliverables. But once we get into the first MVPs or the first prototypes of things, that's where we want to work with the industry and the researchers, understanding how they can utilize and integrate those tools in their working process, workflows, pipelines, and then understanding what iteration can be done over these next few months, so it can really be adapted to the different contexts. So another questions came from Guillaume. He asked, will you permit cloud deployments? Who wants to insert this?
Yeah, I can maybe speak to this. Because I make a bit of an assumption that kind of what's desired is hosting some of this functionality, say generative animation functionality in the cloud, and then being able to call to that. I guess maybe Guillaume, you can correct me if I'm wrong with that description.
No, that's exactly it. Like, can you deploy it on AWS systems or any other type? If you have like heavy workload and you want to be able to just deploy, because you maybe you're an artist and don't have access to a lot of computers from home, but you can just burst it up into the cloud. Will that be enabled or permitted?
Yeah, this is a great question. So it's pretty common to use this kind of deployment for other generative tools. So we haven't started down that path right now. The way that I expect that integration would happen is I spoke a bit to the sort of node-based structure of this system. And my expectation is that would not be a lot of effort involved in creating nodes that call to web APIs. And on those web backends, those services could be anything really. Like if you want to support existing tools, like say some of the NVIDIA generative animation tools, it's possible to integrate those into the pipeline, or to create kind of new generative tools based on what we've created. I don't think within the scope of this project, we would be creating a web deployment of our reference generative animation model. But if anybody who's interested in doing that, that's the kind of thing we'd love to like help out and advise on kind of how that could be done, as well as support through documentation of our systems to make that easier. That's a great question. Thanks very much.
Thank you for the answer.
Right. Another question that came from Andrews. He asked, is the API designed to ultimately work in the capacity where one could effectively use natural language to ask for an animation, say, character urgently runs across the room and kicks the balls, and M-Body would generate the FBX that could be retargeted to your own character?
Yes, that's a great question. So I will say, without any proof to back it up right now, that we have already implemented this as an example use case of our tools. So we do actually have a working example directly in the Unity game engine, where you can type a text prompt saying, a user skipping rope, jumping rope, and you get back an animation applied to a character in Unity as a result of that. So that does exist. The thing that I want to emphasize is we've created that more as an example of how to leverage our tools. So the API to the M-Body library is very generic. So it's really just about being able to create pieces of functionality and wire them together. The specifics of that functionality is all kind of implemented in those individual nodes. So for example, the actual piece that's generating the animation based on a text prompt could be something running on a Linux machine through a command prompt. But again, through this node-based system, makes it very easy to integrate that directly into a Unity plugin. And so we will be releasing these examples with our first open source release, which will be coming in a matter of weeks. So I think there'll also be some materials there speaking in more detail about how the software systems work, of course, documentation about the current API. So yeah, hope you'll keep an eye out for that.
Another questions here from Guillaume. Is the user model 100% yours, or is it based on another open source model paper? Is training traceable and ethical?
Yeah, that's like the question that hurts. I saw everybody's face kind of cringe when I asked it. Because it is the first question that's going to pop up when everybody's going to ask, where did this initial training come from?
I answered a little bit already, but so we are doing applied research. So we take academic papers, we don't do it from scratch, and then we test it and we train with our own data. And as Mike mentioned, also we correct the other data sets to be able to enhance. So we are expecting better results from what they did initially by improving the data set first of all. And the data set is captured in-house, so everything is in the ethics. Everything is good on that side. So.
Yeah, and so I can add to that, I guess. The model that we're using for validation, as an example, was the Diffuse Style Gesture Plus. It is MIT licensed and commercially usable. That's the model itself, right, without training. The model is provided pre-trained using talking with hands, as well as separately with 0x datasets. Those datasets are not commercially usable. Therefore, those pre-trained models that exist right now, you would not be able to use for commercial purposes. But we will be retraining that model from scratch with our own dataset. And that is 100% captured by us. We're getting consent from all of the actors that are being captured so that they know what this data is being used for, what data is going to be released. So trying to follow a very ethical process here. And a big part of this is trying to solve this sticky question right now, right? About where did you get your data from? Are you allowed to use it? We want to put data out there that everyone is allowed to use, and where they know, where it came from, to solve that problem a little bit in this little area.
So in the end, you will have both, like the pre-trained model, if you want to just use it and it was trained on our dataset, but also the dataset in case you want to train another model.
Exactly. Yeah.
All right. Maybe I'll pass the mic to Nico, because you have your question is comments and opportunity. So you introduced the idea of teaming up with Meshcapades and the group around Michael Black. Can you tell us a little bit more about that?
Yeah, I'm like this current initiative. I find super exciting because you're focusing on interactive behavior, whereas I've been working with Michael Black over for the last 10 years a lot. Initially trying to solve the problem that I always found very striking, namely that there's so many motion capture data out there in the world, but everyone collects them slightly differently with different marker sets and different technology, and it's very hard to merge them into one. Well, it used to be very difficult to merge them into one big data set that you can really use for big data machine learning. And so the early models developed by that group around Michael Black, MOSH was the first one called, and then there were different different versions of SMPL, simple, had the purpose to come up with a generic representation to which you can fit like all sorts of data, independent of which marker sets you use, and what technology you use. And that resulted in what's called the AMAS system right now, which keeps growing and growing. And most of the data are from individuals, not from diets or from social groups. And moving from individuals to social behavior, I find super, super important. And it's a focus of my lab at York University right now too. Not just in the full body motion domain, but one we are also using like Apple hardware to track faces interactively, and we do lots of work on eye contact behavior. So the eye movements haven't been mentioned today, but for many applications you don't need good models for that, but for others you do need dyadic or multi-person eye movement data in order to understand this choreography of eye contact behavior better. But I think the technologies that Michael and his folks, and particularly one of his like former technicians, Noreen Mahmood, who's now running Meshkapart, have put forward is so useful and so rich. And I think it would apply perfectly to what you are doing, except maybe that lots of the data that go into that database are not commercially usable unless you pay license fees. And then even some of the algorithms you either have to pay for if you use them commercially, or you get, like, you trade in data for the processing of them. So one of the philosophies of this AMAS project is that everyone can contribute data for free, and they get processed in like very usable ways, but then they become part of the larger AMAS project that then everyone can use unless you make money with it. And so that's the idea. But anyway, like most of you probably know about that world, but I wonder why it didn't come up in the discussions today.
Oh, so specifically the AMAS data set?
Yeah, the AMAS data set and the representation behind it, simple. So the SMPL model.
Okay, yeah, I mean, this did come up quite a bit in our background research. So looking at simple and I guess simple X or
simple X
Base plus, yeah,
all sorts of extensions now that include hands and faces now, and
yeah, and if I recall, and any of my colleagues can correct me if I'm wrong here, but there definitely were some questions about the commercial usability of those systems. Even the representation, I think, seemed like it was not really usable in a commercial context, so very much research focused. So that was the main concern there. That being said, you know, we're putting this data out there to be used, so it would be, you know, great to see this data incorporated into that AMAS data set, to see people, you know, they would have to retarget it if they want to apply it to those skeletons, kind of the simple skeleton model. But yeah, really hope people can do that. And I will just add a comment. I love that you mentioned about the social interaction, about the eye contact. This is a huge consideration for us. And it's why we're capturing the data with multiple agents, why we're preserving the proportions of all the characters. So we will be releasing that kind of accurately proportioned data so that, you know, if two characters were looking at each other, they will actually be looking at each other in that skeletal data as well. So yeah, that was a very big consideration. And then also what was mentioned, 3D scans. So we want it to be the case where if somebody was, let's say, putting their hand on the other agent's shoulder as a gesture, there should be correct contact there. once you go and retarget, you're going to have all sorts of issues like the hand separated from the shoulder, intersecting, and you don't want to be training a model to produce animations that are incorrect like that.
And I just wanted to add that during the CVPR conference, I actually talked to the Mishkapate team, and they seemed very interested in our work, and we were planning to have a conversation with them as well, like to know their input.
That's a good thing. Yep, really, the CEO, Noreen, she's so, like, she's very nice to work with, and she is, like, I bet she would be interested in contributing if it's possible from a business point of view. Yeah.
Oh, I think we went through every questions that were already asked. Just giving everyone the opportunity. There's still we still have some time if you want to have any chat with us. In the meantime, I can just remind that we will keep in touch. We'll send a follow-up form so we can start more of a one-to-one or demo and engagement in using the different tools that we'll bring out there. There will be plenty of opportunity to give feedbacks, to collaborate. So we talked about the platforms and to collaborate to the code, but we'll also provide other opportunities like this to engage and even potential events appearing in the fall. So we will keep you posted through our platforms, the social media, LinkedIn, and direct conversation to the people that replied and in the registration form that wanted to receive information. So Mike, do you want to say maybe the last word for this session?
I think you summed it up pretty well with the collaboration. Yeah, I just want to emphasize, please don't hesitate to reach out to us. If you have any questions, if you're interested to participate, yeah, very much want to talk to everybody out there. We want the results of this project to be used. Our goal is to create value for people, so would love to hear about what would have the most value for you. So it's a great opportunity to be self-serving and to try and steer our project in a direction that you want. We'd love to hear that because we want to know what people need.
Absolutely. So thank you so much, everyone. Hope to see you soon.